This is lesson 11.5, volume of prisms and cylinders. So if we recall, a prism is a solid with two congruent, parallel, polygon bases, and we name it by the shape of the bases. So here, the top and bottom would have been my bases because the top and bottom are the shapes that match. The rest are all rectangles. And here, again, the top and bottom would have been my bases. They would have been triangles, and the rest were all rectangles. The height of a prism or cylinder is the length between the two bases. So it is not always measured vertically. So it's really important to be able to identify which shapes your bases are, and then you're going to find the distance between them to represent the height. So here in our first example, we have a hexagonal prism. The top and bottom in this case are the bases because those are the hexagons. So if I want to connect the top and bottom of my shape, how far apart they are, that would have been this value. So the height here would have been 12. Whereas in B, the two shapes that are different or that are the same as each other are these two triangles. So the triangles are the bases here. The distance between those triangles would have been 8. So 8 in this problem is the height of my prism. So there's 2 here for you to try. You can pause. Answers are posted on Google Classroom. So the volume of a prism is going to be big B times H. And big B is going to stand for the area of the base. And that formula will change based on what shape the base is. If we have a rectangular prism, that means the base is a rectangle, which is length times width. So if I did that, it would really be length times width times height. So for rectangular prisms, if you would prefer to use length times width times height, that's fine. But this formula here is representative of any shaped prism, area of base times the height. In example 2, we have a rectangular prism. I'm going to call the top and bottom the bases. I'm going to try to make the top and bottom the bases in rectangular prisms because it's just easier to call the bottom the base. So here, I can do length times width times height, 9 times 17 times 24, if I was going the length times width times height route. Otherwise, B would be 9 times 17, H would be 24. I know I'm showing it 2 different ways at the same time. So here I could have done 153 times 24. Here I would just multiply all 3. And either way I've chosen to do this, I get a volume of 3,672. And my units are always cubed, so these were centimeters, so centimeters cubed. Again, whichever way you feel more comfortable. If it is a rectangular prism, that's fine. So here's a check-in. You can try, pause, answers are posted on Google Classroom. In example 3, we have a triangular prism. So we are no longer able to just do length times width times height. So my base is a triangle. And I'm going to redraw this so that this and this look more like this. So I have a base and a height to work with. So the part that was inside was 7.3. This whole length here was 12. So for this area, since it's a triangle, it would be 1/2 times 12 times 7.3. So that is 43.8 for B. The height, the distance between the two triangles, was 5. This 10 is not going to get used at all. All right, but now I have my B and I have my H. So volume is B times H, 43.8 times 5. This time my volume is 219. The units were feet, so feet cubed. So here's a check-in for you to try. Be careful. The triangles are in the front and back. It's not the bottom. Pause. Answers are posted on Google Classroom. In example 4, you're building a rectangular chest. You want the length to be 6 feet, the width to be 4 feet, and the volume to be 72 cubic feet. What should the height be? So right now we have a rectangle that's 6 by 4. So the area of the base is 6 times 4, or 24. The height is unknown, but the volume is 72. If I take V equals B times H, then 72 equals 24 times H. And if I divide both sides by 24, I get that H should be 3 feet. Here's a check-in for you to try. You can pause. Answers are posted on Google Classroom. A cylinder is very much like a prism in that we're going to do area of the base times the height, but this time the base is always a circle. So instead of having to put B there, I can put pi r squared because that's always the volume, the area of a circle. So pi r squared H will be the volume of a cylinder. And R is going to be the radius of the base, and H is still the height, the distance between the circles. In example 5, we are given the two circles are the sides, which means the height connecting them is 21. So H is 21. And R would be the radius of that circle. I want just the radius of this circle. The whole diameter was 11, so if I divide that by 2, R is 5.5. So now my volume, which is pi r squared H, would be pi times 5.5 squared times 21. What I'm going to do in my calculator, I'm going to do 5.5 squared, then times 12, and times pi. I find doing my squared first, make sure I'm not accidentally multiplying before I squared things. And I'm also going to use the button on my calculator that has the pi symbol. So some calculators, it's on the left-hand side, just kind of midway. Some calculators, it's at the bottom, and you have to hit like second or shift to get to it. So you have to look at your calculator and look for the little pi symbol to use your pi button. If you can't find it, you could always use 3.1416. It's good to go those 4 decimal places to get a little bit more exact. You'll get further away from the true answer if you just use 3.14, the bigger the problems are. So here's our check-in. You could pause. Answers are posted on Google Classroom. In example 6, if a cylinder has a height of 7 inches and a volume of 2,908.33 cubic inches, find its diameter. So I'm going to start knowing that H is 7 and V is 2908.33. So if V equals pi r squared H, then 2908.33 equals pi r squared times 7. So if I divide both sides by 7, I get 415.5. Now I'm going to divide by pi. I'm going to use the pi button, remember. 132.25 equals r squared. And whenever I have something squared, to undo that, we can take the square root of both sides. And when I do that, I get that r is 11.5. My units were in inches, so my answer is in inches. So here's a check-in for you to try. You can pause. Answers are posted on Google Classroom. So let's recall again mass, density, and volume. Right? Mass is equal to density times volume. Volume is equal to mass over density, and density is equal to mass over volume. So in example 7, the diagram shows the dimensions of a standard gold bar at Fort Knox. Gold has a density of 19.3 grams per cubic centimeter. Find the mass of a standard gold bar to the nearest gram. So we know mass is equal to density times volume. So I need to know both of those values. I was already given the density, but I don't yet know the volume. I'm going to find the volume first. So this is a rectangular prism, which means I can use length times width times height. So we're going to do 17.78 times 9.2 times 4.55. And we're going to get a decimal. That's okay. We're going to write the whole thing out. So my volume is 727.9132. So mass will equal 19.3 times that number that's in my calculator. So if I hit times 19.3, I get a mass of 14,048.7. Oh, they said to the nearest gram, so we'll round that to a 9 grams. There's a check in here for you to try. Pause. Answers are posted on Google Classroom. In example 8, a solid plastic cylinder weighs 13.5 ounces. The cylinder has a height of 4 inches and a radius of 1.5 inches. From this data, what is the density of the plastic to the nearest thousandth? So again, 3 decimal places later on. We know for density, it's going to be mass over volume. Once again, we're given our mass, but we are not given a volume of any sort. So we're going to find the volume first. We know we're going to do pi r squared times height. It said it had a height of 4 and a radius of 1.5. So my volume, squaring the 1.5 first, then multiplying it by 4 and pi, gives me about 28.27. 28.3 is my volume. So density will be the mass, 13.5, divided by the volume, 28.27. And I got 0.47, and that's the next 7 will turn into an 8. And let's look at my units. The density, the mass was ounces. The volume was inches cubed. So this is ounces per cubic inch. This is the last one for you to try. The answer is posted on Google Classroom. And that's the end of volume of prisms and cylinders.